Welcome to this week. This is about logic gates. First of all, let's start with the simple electricity that you and I use. Now, how do you turn this into a working computer which can work out adding your numbers to playing your favorite video games? Well, it's all done by using something called a logic gate. Now, electricity can either be on or off, which is why what you've been looking at the last few weeks is binary. Binary being our ones and zeros, in which we can represent numbers. Now, the easiest thing, which is why they used binary, was because a 0 would be represented as off. That's electricity turned off. Then a 1 would obviously be on. Hence, that's why we can use electricity to represent and use this to manipulate numbers. And that's why computers are really good at this. So they use electricity, which is simply on and off, and we can use this then for our binary data. And as you've seen, binary can represent numbers, but also can represent letters and graphics and sounds, all using very similar principles of just on and off. But we need a way to control it, where we see ones and zeros, and that's where logic gates come in. So let's have a look at a logic gate. So let's look at electricity. Here we've got a simple switch and a light bulb. Obviously, when you turn a switch on, your lights light up, and when you switch them off, the lights go out. Obviously, electricity here. So obviously being off would be a 0, on would be a 1. And computers utilize these switches, but they use a transistor. Now, transistors are very tiny devices. Now, these are what make your digital devices work. They control the flow of electricity. Now, obviously, we can't have lots of these. Allow you to control a flow of electricity, and we do this because we need to make our computers have decisions. Decisions are what we and computers need to be able to do so that they can make choices about numbers, whether to add them or take them away. We know obviously 1 plus 1 gives us 2, but a computer doesn't know that. All it can rely on is whether a switch is on or whether a switch is off. And these transistors are used to control the flow of electricity. These are obviously very large transistors. If you look in a digital device or a modern digital device, these transistors are incredibly small. Over here you can see that each of these tiny specks here is what we just saw as a transistor. So large transistors the size of your little finger. When you squeeze them down onto a CPU on your computer, they are incredibly small. If you look at a measurement, if you think of a millimetre as quite small, we need to go down to a millionth of a millimetre wide, a nanometer, and we can squeeze quite a few transistors in a very small space. We're talking trillions of transistors which can all be printed onto your CPUs. So let's look at the 3 main types of logic gates that you need to know. Now, this piece of software, there is a link below in the Firefly page, and over here you've got toggle switches, so you can toggle on and off. There are lots of things in here, so once you've done this week's work, you are more than welcome to play around with all the other bits and pieces. The 3 main logic gates, we've got the NOT gate, the OR gate, and the AND gate. Notice the shapes of these logic gates. Now, what you'll realize is that all logic gates only have one output, and the inputs to a logic gate, you can have one or more inputs to a logic gate, but this is the most important part, you can only have one output. Now, these 3 gates here, you can pretty much make and control electricity how you need it to be controlled to process any data in the form of binary in a computer. They have special tendencies and they control the flow of electricity individually, and they represent different ways in which you can control electricity. So that's it for the introduction to logic gates. The next video further down in the Firefly will be showing you how you can investigate these three logic gates, and you can yourself work out what each of these does and how you might think it's used in a computer. So again, quick recap: binary, use of ones and zeros, so electricity states of on and off, and then our logic gates, which we can then combine states of on and off, and we can make decisions in our computers.